James Webb Telescope just discovered an irregular galaxy orbit, the Milky Way. There were many unknowns about the universe when scientists conceived and developed the Hubble Space Telescope, the most innovative astronomical observatory of its day. But did you know the NASA James Webb Space Telescope has revealed many unbelievable things to us? Yes, it has. Let's check it out. Welcome to our channel, where you get real updates about space and technologies. In today's video, we are discussing James Webb's telescope just discovered irregular galaxy orbit in the Milky Way. Don't forget to hit the like and subscribe button and also smash the bell icon so that you can be notified when we release a new video. Kindly stay tuned to the end of this video to know the latest discovery of this amazing telescope. Thanks. NASA's James Webb Space Telescope was photobombed by thousands of ancient and distant galaxies when it took its first in-focus image of a single star. This $10 billion observatory will require a lengthy commissioning process, which will include aligning and focusing each of its 18 mirror segments. The foreground star, 2-mass J17554042 plus 6551277, located 2,000 light-years from Earth, yet surrounded by background galaxies millions or billions of light-years away, hints at the origins of the universe. The Webb telescope has issued an engineering image, but there will be no beautiful photographs or scientific disclosures until later this summer. When the 18 hexagonal mirrors were examined to see how well they functioned together for a single synchronized image, it was better than expected, offering a significantly more focused vision of the universe, which will improve scientific metrics. NASA anticipates Webb to meet or exceed the observatory's science goals as a result of its enhanced optical performance. More than 2 decades ago, the Webb team set out to develop the most powerful telescope ever installed in space, and they came up with a unique optical design to meet demanding research goals, said NASA Associate Administrator Thomas Zubushin. We can safely assert that design will deliver in today's environment. Webb was launched from the European spaceport in French Guiana on Christmas Day last year and reached its final orbit around the Sun on January 24th. It has spent the previous few weeks adjusting its mirrors using a succession of technical images to bring them into focus. Last month, NASA studied a much closer star using a mosaic of 18 unique photographs acquired from the star's mirror sections. The researchers were overjoyed as they awaited the delivery of the most recent batch of test images. NASA's test image was 100 times fainter than the human eye can see and focused on a star 2,000 light-years away. A light-year is 6 trillion miles long, 9.7 trillion kilometers. The background, on the other hand, really stole the show, thanks to the design of Webb's mirrors and filters. You can't help but notice the thousands of galaxies behind it, which are extremely beautiful, said Jane Rigby, Webb Operations Project Scientist. These galaxies have existed for a very long period. Astronomers anticipate that Webb will be able to travel back in time, a couple 100 million years after the Big Bang, as she put it. Extinction astronomer Jennifer Millard described some of the galaxies in this image as lovely on Twitter. A spiral galaxy near the bottom of the image appeared to be colliding with another galaxy. There were also face-on spiral galaxies, which demonstrate how a galaxy like the Milky Way may appear from above. There were galaxy clusters, recent galaxies merging, and even some galaxies from the early universe discovered. Some are faintly visible glowing blobs in the image's foreground. According to Dr. Miller's tweets, the longer you look, the more small blobs you notice, and these, she claims, are the most intriguing and oldest. Webb won't be able to see the oldest galaxies with merely a 35-minute exposure. Those that are older will require more time to observe. However, it will take more than 35 minutes of staring to find the first stars and galaxies. Imagine how full this will be after 10 days of looking into space. Some of the background galaxies were compared to pictures taken by ICRAR astronomers Luca Cortesa using Earth-based observatories. The incredible was fun to compare, as it is for many astronomers. It's impossible not to be astounded when using actual data. Everyone involved ought to be applauded and thanked for their efforts. This will be an exciting journey, she wrote on Twitter. The $10 billion tennis court-sized telescope's 18 mirror segments have been perfectly positioned to within a hair's width. Despite this, the focusing team's work is far from done. This is merely the most recent major milestone in the telescope's development, preparation, focusing, and cooling. During this step, every optical parameter was examined and confirmed to be performing at or above expectations. The study also confirmed that Webb's optical path was devoid of pollution or impediments. Light from distant objects can be easily gathered and transmitted to the observatory's instruments. The achievement of this milestone indicates that the team is confident that Webb's first-of-its-kind optical system is functioning as well as it can, even if there are still months to go. An astronomer and European Space Agency scientist Mark McCaughan said that the cleanest possible images were being sent to Webb's sensors. As a result, we can dive deep and examine a lot of detail and provide the stunning science envisioned decades ago. The galaxy clusters and galaxies visible in the background of the amazing blazing star image hint at what Webb will reveal once finally online. Look at some of those galaxy clusters in the background, tweeted Hannah Wakeford of the University of Bristol, who investigates extraterrestrial life. At every turn, this telescope is going to blow our minds. We can even observe the atmospheres of otherwise inaccessible planets by measuring them with a single beam of light. It is able to achieve this result because of its unique optical system and design, which required it to be folded for launch and progressively unfurled over a month. Unlike some of the world's largest ground-based observatories, Webb is the first space observatory to include a segmented primary mirror. This beryllium mirror measures 21 feet 4 inches in diameter and is made out of 18 hexagons. Once in orbit, the spacecraft's individual mirrors were fine-tuned to within nanometers in order to generate a large reflective surface capable of gathering even the smallest amounts of light. Because of Webb's ability to detect infrared light at low levels, astronomers will be able to peer into the early universe or find faint atmospheres on distant worlds. Webb has pioneered a novel way for building space telescopes, said Lee Feinberg of NASA's Goddard Space Flight Center in Greenbelt, Maryland. It has enabled Webb to achieve excellent science. The University of Arizona's near-infrared camera assisted NASA's James Webb Space Telescope in reaching this milestone. For the past few months, a camera called IRCam has been used to focus each of the 18 mirror segments, resulting in mosaics of 18 photos of the same star. The mirrors were then perfectly positioned to provide an image of a single faraway star. This photograph's target star is different than previous ones, but it is still clearly visible. The Webb crew decided to take one more selfie with them now that the major mirrors are completely aligned. Instead of being slightly out of focus, the image appears clear this time. In February, NASA released a snapshot of the 18 mirror segments from the secondary mirror's perspective. One of the mirror segments shined brighter in the selfie photo because it was pointed at the bright star HD 84406, while the other 17 did not. Because the mirrors are exactly matched, all of the mirror parts in the most recent selfie now reflect wonderfully. This image was captured within IRCam using a modified pupil imaging lens. While the engineering images taken thus far are significant, the observatory still has a long way to go before it can begin full scientific operations with all 4 of its instruments. When scientists expect to see the first beautiful images taken for research objectives, summer is the season. Demonstrating this great optical performance ensures that IRCam will yield the science results that everyone is expecting, said Marcia Reiki, the project's main investigator and an Arizona State University Regents professor. Webb's primary imaging camera, IRCam, has now been fully aligned to the telescope's mirrors following the completion of the telescope's fine phasing stage. A star in our field of view was observed with the telescope at its optimal alignment and focus, and the results were unexpected. Ritva Kishakua, NASA Goddard's Deputy Optical Telescope Element Manager, stated, "We are really thrilled about the implications for science. To put it another way, we now know we built the correct telescope. We are optimistic that the telescope will reveal the minute details we seek." The team that will align the telescope with the near-infrared spectrograph, the near-infrared imager and stiltless spectrometer, and the mid-infrared instrument, or MIRI, is led by Arizona Regents Professor of Astronomy George Reiki. The remaining alignment steps will be completed within the next 6 weeks by the team. During this stage of the process, an algorithm evaluates and corrects the performance of each instrument in order to establish a well-aligned scope across all science equipment. Following that, Webb's final alignment stage will begin, and the crew will rectify any remaining placement errors in the mirror parts. The optical telescope element alignment is projected to be finished by the beginning of May, if not sooner, and the crew will then begin the 2-month preparation period for the science equipment. Some have referred to the James Webb Space Telescope as a time machine that holds the key to deciphering the cosmos mysteries. The telescope will be used to investigate the origins of stars, exoplanets, and even our own solar system's moons and planets, stretching back to the first galaxies that formed 13.5 billion years ago in the early universe. The operating temperature on the James Webb Telescope and most of its instruments is around negative 387 degrees Fahrenheit, minus 233 Celsius. According to officials, the $8 billion program cap required by Congress may be surpassed. The NASA Space Agency has already invested $7 billion in the telescope. It will be the largest and most powerful telescope in 2021, capable of peering back 200 million years before the Big Bang. Did you think the future telescope to come will do more than this? Kindly comment down below. Don't forget to like and subscribe to this channel and also hit the bell icon so that you can be notified when we release a new video. Thanks.